Welcome back. So let's jump into today by taking a look at the terminology. Ordered pair is pretty simple, and you guys are familiar with a coordinate ordered pair such as x, y. We can plot that on our coordinate plane, and that's simply just an ordered pair. Now, an independent variable, also going to be known as your inputs, and this is the known value in an equation. And it's going to have a specific value that we plug into that equation, and it's going to allow us to calculate the dependent variable, which is the output or the result of that equation. Now, it is the unknown value, and it is going to depend on what the input is. A relation is simply any set of ordered pairs. However, a function has to have particular properties about those ordered pairs. Specifically, it is going to be a set of ordered pairs, x and y, in which each first component, or the x, is paired up with or matched with exactly one second component, the y. In other words, the set of ordered pairs cannot have a repeated x value. So that's a little pro tip for you. All right, so let's take a look at these two examples just to see what I mean here. This first example, we have this relation 1, 3, 2, 5, 3, 0, and 4, 5. Now this is going to be considered a function because it has no repeated x values. However, this one here, 1, 3, 1, 4, and 2, 5, is not going to be a function because you can see these first two ordered pairs have a repeated x value. Now, when we plot those, we're going to be able to visually see that on our graph, and we'll get an example of that coming up here. All right, some more terminology. We're just going to highlight a few things here. If the relation is a function, like we saw right up here, then we say that the dependent variable, that's our y variable, is a function of the independent variable. In other words, the dependent is a function of the independent. The y is a function of the x. All right? We also say that the function maps each value of the independent variable, the x, onto the corresponding y value or the dependent variable. So again, a little bit of terminology that you'll hear us use in class. Let's jump into examples for today. Example 1, we're going to take an Uber ride in New York City. How exciting. We are going to be charged an initial fee of $2.55, and each additional mile is going to charge us $1.75. We're going to write a mathematical model or mathematical equation that represents the cost, and it can be seen as this. The cost is equal to $2.55 plus $1.75 per mile m. Identify your independent and your dependent variables. So I always like to ask myself the question, which variable, cost or miles, depends on the other? Here, I'm going to say that the cost I pay depends on the miles that I take the Uber ride for. So cost is going to be my dependent variable, which means the number of miles driven in the Uber is going to be my independent. All right, now if we were to evaluate this equation up here for different values of miles driven, we could imagine driving 1 mile, and that would cost $2.55 plus $1.75. Let's quick do that math. That's going to give me $4.30. There's one ordered pair, which is a relation. I could then take it 2 miles and get that cost for driving that 2 miles. I could do 10 miles, and that would now be, let's quick do that math. We're going to have that's $20.05, so on and so forth. And these are all going to be relations, and this relation will form a function because there will be no repeated x values here. However, some numbers that you couldn't put in for m would be like negative numbers because you couldn't hop in an Uber and drive a negative amount of miles. All right, let's take a look at some other relations here and determine if they're functions. And let's also take a look at how we can determine if a relation is a function visually by graphing those ordered pairs on our xy plane. All right, so let's take a look at this first one here. We have 0, 4, 4, 2, 6, and 3, 3. So let's just take a second to plot that. 0, 4, 1, 4, 2, 6, and then 3, 3. So I see here that there are no repeated x values. So this is going to be a function. All right, I can see here also, I can see that I have a repeated y value. However, I don't have repeated x values. Now this is kind of a tricky one here. It's okay to repeat a y value, you just can't repeat x values. All right, so that's what the graph of that first one would look like. Now I'm going to erase those points here, and we're going to graph the second one here. We have 0, 4, 1, 5, 1, 2, and 4, 1. So again, the same point, 0, 4, 1 over and 5 up, 1 over and 2 up, and then 4 over and 1 up. All right, now you can tell from the ordered pairs that there is a repeated x value here. So we're going to say that this is not a function. Oops, and we're going to try to spell that right. That is not a function. Now, the visual on this is that if you see here, you have 2 points that pass through the same vertical line. If we were to draw a vertical line, you would see that that vertical line touches 2 points in that relation. Well, this is called the vertical line test. And the vertical line test says that if a vertical line passes through more than 1 point in a relation, then it is not a function. So a little pro tip for you there, simply graph it out, and if that vertical line, if any vertical line passes through your relation in more than 1 point, it is not a function. Finally, our last one here for this example, we see that there are no repeated x values, so this one will be a function. All right, let's jump into example 3. So relations can also be displayed in table formats. This is just an ordered pair. So there's an ordered pair, 1991, $20.20, or 1993, $16.75. Here we're going to get a little bit of practice using the language of dependent and independent. What depends on the other? And if you remember from a few pages ago there in our notes, we said that it is the y that is a function of the x. It is the dependent that is a function of the independent. All right, so here we have the average annual price P of crude oil per barrel in the year in the year Y. So we have years here in 1991 all the way through 2007. Crude oil here is at $64.20 in 2007. And the question that they're asking is, why a function of P? Why or why not? And what you want to think here is that, does Y depend on P? Does year depend on the price? And here we got to say no. The year in the calendar does not change over based on the price of crude oil. So no, Y does not depend on P. And therefore, here's an abbreviation for the word therefore, 3 little dots. Therefore, Y is not a function of P. All right, now we're going to flip-flop that around here, and we're going to take a look and say, is P, price, a function of Y? Why or why not? So if price is a function of the year, then we have to remember that, yes, P does depend, all right? It does depend on the year, typically based on inflation and monetary values and economic principles. We would say price is going to fluctuate based on the year here. However, if we were to list these ordered pairs and look at this to see if it is a function, then there would be no repeated P values for all the different Y values here. And you can see here that there is 2 values, 1993, $16.75, 1995, $16.75, that are the same P values here. So again, we have to say no, P is not a function of the year. Even though price will change over the years, Here, because there's repeated price values that are the same, P does not depend on the year. It's a little bit tricky, but hopefully we'll get some more practice with that kind of language. All right, next up, let's take a look at example 4, the percentage P of adults in the U.S. population aged 25 and over who had earned a 4-year college degree by the year Y is given in the table below. All right, we want you to graph the relation and determine its function. So oftentimes throughout the course of the year, we're going to end up graphing relations or graphing the data to get a good visual of what's happening here. So we're going to put the years here on our x-axis, and we're going to put P for percent up here on our y-axis. And this is good practice early on at the beginning of the year to really hone in your skills on graphing. So all right, so there's a rough sketch, a sassy sketch of our graph here, of our relation. And we want to determine if it is a function. So we're going to use the visual vertical line test here. And remember, the vertical line test says if a vertical line passes through more than one point, then it is not a function. But you can see any vertical line that I drop through any of these points of this relation will actually only pass through exactly one here. So we're going to say yes, this is a function. This relation is a function. All right, and we can confirm that just by simply looking at there are no repeated x values. There are no repeated years, in other words. It says which variable y or p is the dependent variable here. So we're going to say our percent, and typically we're going to always graph our dependent variable on that y-axis. So our percent depends on the year, and then it's explain what the relation 1994-24 means in the context of the problem. So I put that in bold because this is going to be important as you go on in your study of mathematics, that you really understand the context of the problem. What is this data telling us? What's the story that it's giving us? So here we have to go back to the actual reading and see that P represents the percentage of U.S. adult population over the age 25 who earned a 4-year college degree. All right, so I'm going to say in the context of the problem, it means that in 1994, 24% of the U.S. adult population over age 25 earned a 4-year degree. All right. So being able to go back and really understand what that relation is telling us in the context of the problem is going to be an important skill that we want you to learn.